Nobody's there. Also, check out that picture. Okay. This is a roundup. This is a long fight attack. Singing songs.
Ooh, I don't have any audio control. Sorry about that.
Audio control of what? Are you talking to people in the room?
Oh, yeah, in the room, yeah, because I'm on HDMI. I tried my volume buttons and it was like, no.
You guys don't like to hear all the Radioheads?
It sounds really compressed.
What?
It's really loud and squeaky and compressed.
Cool.
Yeah, I guess that's cool. So I'm going to share the broadcast link out, and then we're going to look at the Hangouts link over here.
Well, so you guys should probably watch the broadcast link and then mute yourself on the other one, maybe? I don't know.
Okay. How do I mute you, though? I don't know how to do that.
Mute.
I can mute the tab. Oh, can I?
Oh, you can.
What? What, though?
It heard you.
Oh, maybe because it's not currently making sounds.
Wait, you can mute your cell phone.
I don't know.
Tell him to go mute himself.
Yeah.
I need to go back in time. And this morning when I thought I put too much food in Tupperware, slap myself.
Yeah. So, Tyler, I was thinking we should share the broadcast one with people that can't be here in Monson, and then use the Hangouts one. They seem to have about the same quality, right?
Oh, they do. Oh, that's fine then. Yeah.
Okay. So I'm gonna do that thing and Bigify. Where's the hello? Someone help me. I can't see the thing.
It's done.
Is it under me here?
Oh, for that? I don't know. Are you talking about
No. There's a way to big. Oh, that is this whole thing. I just need to bigify the thing. Pronouns. There you go.
So that dialect quiz, huh?
Where did
Yeah,
it
you get? It put me at Sacramento and Salt Lake.
It put me in
One's where I grew up, one's where I am now.
It's pretty accurate, huh?
Yeah.
For a lot of people.
Yeah.
It's pretty crazy.
Range left grades was like the telling grade.
Yeah, I just shared the link on WebDevRandom. Said the one for
Okay, cool. That link is out there. Hopefully people will use it so they can watch.
As I was saying that, I was
All right.
I actually didn't have a
Let's go ahead.
Someone from Utah said it, and I was like, oh, I've never had a word for that. I guess I'll start using it. You ready?
Yeah.
Okay. Can you hear okay?
How's everyone doing? Good lunch? Excellent. So I want to start off real quickly talking about some of the apps that we see nowadays. So let's, for example, think about smooth streaming players, or thinking about things like 2Do MVC, Rock My Talk, or to think about code editors, or games, or even Netflix, or even things such as advanced business intelligence, to other more games, and to even things like productivity such as drawing. What do they all have in common? Well, they're all basically reactive-based applications. So what we're going to do is we're going to dive deep into exactly that. What exactly makes a reactive programming program interesting? So now let's go back to the real talk at hand here. So we're going to be talking about how reactive programming has really kind of changed the world and the way you create apps today. So of course, I always want to start off with a little bit of JavaScript just to get everybody warmed up. So you know what this, sup. And since this is all about concurrency, let's just go there and just say, take me down to the concurrency city where green grass is the girls and the and are. It happens. So you may wonder why I wear this stupid hat. So I am a principal software engineer and open sourcerer, as it were. And the reason why I called myself that was because I worked on a lot of things at my company where I truly believe that they had a lot of influence. Things like early adoption of Node on Windows, talking about early F# adoption, including reactive extensions. But also recently, we released React Windows, which is the React Native for the UWP platform that I currently work on. So I'm from, so it's, you might be thinking it's kind of strange. Here's a Microsoft guy with a Mac up here talking at an Angular conference, but here we are. So I'd like to think that I put a little bit of metal back into Microsoft with all the stuff that I do. So primarily, I work on what's called the reactive extensions. How many people have heard of that? Anyone? Anyone? All right, a few people. Hey, and some applause. There you go. So I would easily say that I'm an RX pusher. And what I'm trying to do is trying to relay how exactly reactive programming is really, really an interesting paradigm, especially for us in the JavaScript world. But primarily what I want to talk about as well is people that are using it today. So Netflix, obviously, their idea is that they want to stream movies and TV shows from any device. And currently, they could be a third, they might be more of the US broadband traffic right now. So how do you deal with something like that? Something that big a scale? Well, you really have to do that. You have to think really, really different. So this is the story of how Microsoft, Netflix, and others solve some really big async problems by thinking quite differently about how we think about events. So when you think about the Netflix player and you think about other things such as Microsoft Delve, you think about any number of things, everything about your apps today is asynchronous, whether it's your startup, your player, your data access, your animations, view model bindings, everything about your app happens to be reactive in some form or fashion. or at least event-driven. But what comes with that comes a number of things, such as nightmares that you had to deal with. Memory leaks. I forgot to get rid of my event handlers. I left a few open. I have race conditions between certain events that are happening. I have callback hell. Complex state machines, whether I don't know quite how to read where my code goes next. And so you have all this disjointed error handling because of that, because you now have error handling in 5 or 6 different places. So when Netflix really started this, they had a thing where they had 5 or 6 different languages where they were going about and trying to solve asynchronous problems in different ways. It wasn't until they discovered something like the reactive extensions that it suddenly popped a light for them, that they realized that they could write their entire set of applications using one kind of language, as it were, which is the reactive extensions, which is actually language neutral. There's RX Java, there's RX.NET, there's RX Groovy, Python, Ruby, Rust, you name it, and of course JavaScript, you name it. There are versions for that. So what they're able to do then is they're able to switch people between layers, but they're still speaking the same language. They're still speaking RX. So let's just face a certain thing. Asynchronous programming as we know it today is awful. We live in callback hell, and it's not just because we're too lazy to do continuation passing style and just having the code walk off the page. It's more along the lines of we also have this really complex state machines as to where we're actually handling errors, where we have success conditions, and so forth. And what you end up with is a cow's head. But I think it's even worse when you're dealing with events. So something as simple as doing drag and drop is actually a lot more lines than you think it is, because not only do you have to track mouse down, mouse up, and mouse move, but you also have to track the state in between. So what you always end up with a lot of the times is this poor kid trying to get the data after it's long gone. Poor kid. So promises are great, but they're only part of a solution in the fact that I can now linearize that callback hell that I had before. So I can initialize the player, then authorize the movie and handle the login error if there is one. And then I can play the movie or else it's unauthorized. But that's a great part of why promises are now very useful, is the fact we now have a single value to represent single async values. But there are problems with that. For example, there is no innate way in the promises spec itself to handle cancellation at all. So, for example, in the fetch API that's part of service workers and so forth has no way at all of doing canceling a promise. And in fact, there's a wide array of discussion about this. And if you take a look at this thread, there are 21 participants and 204 comments. So you could ask yourself, how many engineers does it take to cancel a promise? Sorry. But not only that, but there is also certain things that were missing from the spec as well, and the fact that there is no finalization as well. So if you're trying to model something such as I/O, which very much has a notion of cleanup at the very end, as well as any cancellation, like you get halfway through uploading a file and you want to stop, well, then promises as specified today do not have that solution. I hope in the future that they will. And that's all I'll really say is I would really, really like to see it happen. So it really is the final countdown, in the fact that it doesn't have it. So one of the most common things that people try and do and to explain is why it's interesting. How many people have implemented type ahead search? How many people have done it right? How many people have done it under 200 lines of code? Wow, a few people here, brave souls. So I did it in jQuery just to show you how it's done, and I did cheat just a little bit in using ES6 syntax here, but you can tell there's a way to call the JQXHR, there's a way of debouncing, there's a way of retrying if there are failures, etc., etc. So it's write more, do less. But let me ask you, can we do better? Well, I think so, because it really is a national priority of ours. Even back in the 1960s, when we choose to solve asynchronous programming and do other things, not because they're easy, but because they're hard. But then he soon realized that was not really the case, and it was easier just to go to the moon, I think. Anyways, so callback hell we can actually solve in a very reactive way instead. So when we think about flat map or something like that, we're really talking about chaining one observable or one continuation to another. So don't really think too hard about it just yet. But the idea here is that we're taking it, initializing it, taking the player attempts with the movie ID, authorizing it, trying it 3 times, and then take until canceled. So for example, halfway through and it's taking a really long time on my network, I can hit the cancel button. Suddenly it goes away. Everything in terms of its initialization and everything else just goes away. Now the same thing with that mouse drag example that I showed before, where we had certain things with showing mouse drags. Well, here we combine the flat map with, we take the mouse down and the mouse move until mouse up. That was simple. And even type ahead, where I showed you really hard code, was really just getting the value, debouncing it just a little bit, so if I'm a really fast typer. And not only that, but I also handle out of order requests that come back, and then I can retry 3 times. So what you'll find is it's really actually harder to get burned that way. So much better. So what is reactive programming exactly? No, it ain't this. Nope, not this either. So what it is if we want to go to the dictionary, it says readily responding to a stimulus. Okay, well, we've been doing that for a while. Isn't it more than that? You know, because us hipsters, you know, those with us with beards who have been doing reactive programming for a long time said, yes, you kids, we've been doing this for a long time. But you really want to know what it is, you can go ahead and read a paper. But, you know, just be prepared that most papers leave you kind of somewhere like this, and I understand that. You know, even the most brightest of us have those kinds of reactions when we're looking at academic stuff. And those industrious Germans really do have a word for it. So what else really makes up reactive programming? I would certainly say react to load, obviously. You know, when do you start shoving things down your shirt is certainly one of those things. React to failure as well. You know, when do you bail out? And how do you react to your users without giving them the beach ball of doom? So back in 1994, I don't know how many people were born back then, but there was this book of the Gang of Four. An iterator and observable were 2 of those patterns, but they were never connected. But let me ask you this. What is the difference between an iterable, what we see here, of just simple coordinates and an event? And I'd like to say that absolutely nothing. They're both collections of some sorts. Arrays are simply collections in memory, and events are collections over time. That's it. So we already have the iterator pattern in ES 2015 where we can call .next, and it gives us whether its value has a value or it's going to next, and then finally you get true. And the same applies to what we've always been doing in JavaScript as well, with DOM add event listener when things go. But right now what it is pull versus push. This add event listener tells us when it's ready, it will give us things. So it's really the what I would say is the subject observer pattern that they have, but done right. So what we have is the observable here with a subscribe, and that subscribe takes in an observer. So that observer takes in, so it says, notify me when there's something next, when there's an error, and when there's a completion. And then I hand you back the subscription. That subscription then will allow us to unsubscribe at any point and clean up the entire chain. And we have a certain grammar to it in the way that it actually works, so that, for example, if we have a couple of values and infinite values, we keep going. We can keep going, we can end on errors, we can end on completion, but we can never have overlaps, and we can't have things happen after the fact. So now we have this notion of a first-class async value. Really kind of cool. You can create one, and you can return one from a method. So it's great for testability purposes. So when we think about where it fits, we've got object for single value synchronous and iterable for multiple value synchronous. Then we have the promise for asynchronous single value. But then we have observable. So observable, as you can see from iterable, is the same exact code. So you kind of realize, wow, everything really is a stream. So if you understand a few very small things, very small functions, you can understand a lot. Map projects one value to the next, so it doesn't mutate the existing collection, it creates a new collection. We can filter, so I can say I only want circles here. I can do the flat map. Well, that gets a little bit more difficult, but you can just think of it as a map, then a flatten into a single stream. So whatever you do, you must flat map it. So the future really is here. With Angular 2, a lot of things have started to become observables themselves. As you'll know, the HTTP module and so forth really became a core part of what of Angular. And what's really cool is we can take that same type of head search that we had before, turn it into an ng form control with our async pipe, and then we can go ahead and do our search. Since search is nothing more than an observable, we can say get and then map. And then here we can do our Wikipedia thing, which is value changes for that particular term or that control, distinct until change, and then switch map. Now we can also do more advanced things such as video lists. So if you're imagining on a very constrained device, you only want to keep in certain things on the screen if you can help it. Now, I'm not going to necessarily dive through this, more along the lines of it's going to go through there and start to pull whether or not the actual frame or row is in sight. And if it isn't, then that take until row hides basically gets rid of it and all of the associated events and so forth with it. So it's really great for constrained devices as well to make sure that you have nothing dangling. And even the Netflix player itself, when you take that callback hell, we had that what we showed before. Now, Slack for Windows, if those who actually use Windows around here, they have implementing spell check and a lot of other things as part of Slack. So once again, I'm not going to necessarily go through this, but I'm showing you the power that people do. So for example, when you're typing, and then when you stop typing, it's going to start figuring out what language you happen to be using. And not only that, but then starting to do suggestions based upon what you've typed. If you've typed in TEH and you meant THE. So NGRX, really, really cool stuff. Rob Wormold has done some really cool stuff there with Angular and so forth. How many people have heard of Redux? Good number of people. Okay, what if I told you it's only one line of code in RX? Scan. Yep, there it is, right there. Some say it's a two-liner using scan. It very well be, and it is. So once again, on the server, you've got the same kind of thing. You can do really advanced stuff, like I said, the React to users, React to everything else. I think it's very, very important for Node as well. What's also really cool is the fact that it's actually hopefully coming to become a standard as well, where we can start writing these instead of needing anything else. No frameworks or anything like that required. So with that, I would like to take off this hat for just a moment, and I really would like to make reactive great again. So we're going to go ahead and build a wall around all those non-reactive frameworks. It's going to be huge, and we're going to make Google pay for it. So, thank you very much.
You guys still there?
Yep.
Woo! Okay, this one is from egghead.io, and I really like this one because it explains it a lot more.
We'll start with this simple button with an ID of start and with a label of start so that we have something to click on over here. And we'll import observable from rxjs/rx. We'll find our button so that we can use it with the query selector. Look up the start ID, give that a reference, we'll just call this start button. And now what you've probably seen in RxJS examples or docs is using something like from event to use that element, the start button element, listen for clicks, and then subscribe as a way to handle the clicks. So I'll just use an arrow function, this will handle the event, and we can log out the click event. So we'll hit save, click start. You can see we get our mouse event down here. And every time I click start, we'll keep getting that mouse event. So similarly, if we wanted to set up a timer or interval every 1 second, and we want to subscribe to that, and this function actually gets the count of how many times it's kind of ticked through that time. So we'll log that out. Hit save, and you can see it's logging out 0, 1, 2, 3, 4. And if I click the start button, I get my mouse events. So if I want the start button to start a timer like this interval, then you probably think you can just cut this block of code, change this from a one-line inline function block to an actual block, and paste the code in there. So you'd think from experience, I have a button, I click on it, I handle that click with subscribe, and then I create an observable and then handle those ticks with another subscribe. So when I save and do this, so I'll click start, you can see it works just as expected. But this is wrong. Do not do it this way. Do not have multiple subscribe blocks nested inside of each other. For one, you'll lose the ability to save this stream and reuse it, because when you call subscribe, what comes out of subscribe is a subscription, not an observable. So I could not pass this around and reuse it in other places. Also, if you try to do this right now and click multiple times, so I'll click start, and start, and start, and start, and start, you'll see that I'm getting this behavior where it's creating an interval every single time I click. And for a stopwatch, that's not what we want to happen. So instead, what you should think about is when I click the start button, so the start button click, I want to switch over to an interval observable. So instead of saying I want to subscribe to the click, you want to say when I click, I want to switch map, or basically switch to, and this takes a function which should return the observable we want. And the observable we want is this observable interval, so I'll cut this out and paste it in there. So now the way this reads is from my start button, when I click, switch over to an interval, and when I subscribe to this, what the output is going to be is those ticks. So I'll hit save, I'll click start, and clicking on the start button switched over to the interval and is now logging out each of those ticks. And if you wanted to use this first observable, the from event one, to define how the second one that it's mapping to should work, then you can still take the event and do something like create an observable with an interval of event.x, meaning the position I click on the mouse button is going to determine how fast that interval runs. So if I click really far to the left here, it's going to go super fast. And if I click farther over to the right, it'll slow down a bit. So super duper fast and just a little bit slower. But I'm going to undo that because I just want an observable with an interval of 1,000 or 1 second. And the other thing I can do now is if I want to pull this out and say this is my interval observable, and then I can just drop it in here. And I can even pull this out, saying that this is my start observable, and put that right there. This now works the exact same way. I'll just click, and it'll tick every second as expected. Also, I can even define this one. So I'll cut this out. I'll say start interval, and then use that down here, start interval, hit save, and then clicking start will again trigger that same timer. So instead of thinking of that original nested event handler way, that line of thought, think of I have something that's going to fire that when that fires, I want it to start this other thing so that eventually when I subscribe to it, this is the starting event. But these are the things that are going to come through. It's going to switch over to this interval, so we're starting a timer. And one final notable shortcut is if you don't need this event or the thing coming from the original stream, you can say switch map to, and that'll save you from writing that arrow function. Just pass in the observable itself instead of passing in a function that returns an observable, so that when I save, we get the exact same behavior. It just saves us a few characters of code and maybe makes it a bit more readable.
All right, that's it for that one. I would like to keep showing egghead.io stuff, but they probably wouldn't like it since it's the subscription. That was the only free one.
Oh, yeah. They
probably don't want me broadcasting that. Okay, and then the last one I have is from NGConf as well. I looked at some other ones and they were a little bit longer from some of the guys that are kind of made RxJS, like Ben Lesh. It's a little bit longer and not quite as in-depth. And I really liked this one because it kind of showed a real-world example. He kind of shows how to use RxJS with Angular. But he shows a Redux pattern, which I think is quite interesting.
Hey, everybody. So I'm Rob Wormold. I'm the developer advocate for Angular, or actually one of the developer advocates for Angular now. You can follow me on Twitter at Rob Wormold. But today I'm actually not here as a developer advocate for Angular. I'm here as part of the NGRX team. So I'm here representing all these awesome contributors. So I just wanted to give a shout out to these people because this has been a project that's been around for 6 months or so. And these people are awesome. A couple of them are here today and they've been doing really good work. So can everybody give them a round of applause to start with? So NGRX, we have a pretty cool logo, I think. I designed that one, right? So what is NGRX? It's mission to provide a suite of lightweight, interoperable reactive services and components for Angular 2. Kind of our mission statement is that services should be usable in isolation. They should work together seamlessly. They should embrace reactive principles. And of course, if you've watched any of my talks before, everything is a stream. So NGRX today has a few pretty interesting modules. So we have NGRX Store, which is what we're going to talk about today. We have NGRX DevTools, which we'll also talk about today. We have a router, NGRX router, and I just want to shout out for Brandon and Mike. They've been working on this alternate implementation of routing for Angular 2. I think it's super, super cool. I want everybody to try it. Give us feedback. Let us know. I think it's a really, really interesting idea. And then we have this new NGRX DB, which is an IndexedDB kind of reactive setup for Angular 2. And just as a note, people make fun of us all the time because I'm not big on having really shiny names, right? So it's very descriptive, right? Store, DevTools, right? That's what we do. It's very simple names. So in the future, we might have some more stuff, again, with really, really super interesting names. So resource might be a replacement for the $sign resource that everybody loves from Angular 1, right? Everybody loves that one. the socket thing, we'll have an API library. And I just want to say, if you have an idea for something reactive in Angular 2, please ping me. We'd love to have your stuff under our organization. So it's the whole kind of idea of NGRX is we want to have a place for really cool stuff that people can come and be sure they're getting high quality stuff that has tests and works, and just works as a really good companion for Angular 2. So what I want to talk about today is NGRX store. And so we kind of call it Reactive Redux for Angular 2. Anybody in this room used Redux before? You could yell because I can't actually see any of you. So yeah, cool. So what's Redux? And this is like where you gasp because I'm on the Angular team and I have the React logo, right? It's like, oh my God. But I'm allowed to do that. So Redux is a predictable state container for JavaScript apps. Helps you write applications that behave consistently, run in different environments. And this is something we are kind of interested in as Angular developers. Are easy to test. Again, this is something that as Angular devs we really like, right? It's a big deal for us. Provides a really good developer experience, such as live code editing, and then this time-traveling debugger. So Dan Abramov introduced Redux 2 or 3 years ago at a talk very much like this one. It was React Europe, I think. And he showed off this time-traveling debugger that literally blew my mind. And we'll show that off today because we built one too. So there we go. So it's called Redux because it deals with this concept of reducers, right? So everybody's probably done reduction in JavaScript before, but if you haven't, let's do a quick review. So a reducer or a reduction function is a thing that takes a value or an accumulator, if you like the total here, and then some value. So it does something, it returns a new state. So if you've used reduce before, right? 1, 2, 3, we reduce it with this sum function, we give it the initial value of 0. Anybody know the answer to this? What's this going to pop out? 6, yes, well done, good. So if you want to get a little more interesting, right, like you can start to expand this reduce idea, and this is kind of what GRX and Redux do, right? So if you wanted, instead of passing just an array of values, you could give it an array of what we call actions, right? So it gives some sort of instruction to this reduction function. So in this case, we're going to give it we're going to have a counter function that takes the total and an action, and if the action is increment, then we'll take the total and up it by 1, and if it's decrement, we'll do it and remove it or down it by 1. And then again, we just take this array of actions, reduce it, and that would give us a total of anybody. Excellent, good, you're all paying attention. So this is kind of basic stuff. And again, you could expand this concept a little bit further. So if you wanted to manage, let's say, to-dos, right? Like everybody builds a to-do list, you can do the same thing, right? So you dispatch an action of some sort, and then you change the state, which in this case might be an array of to-dos, right? So again, if we add, we're going to concat that to-do to the end. If we delete it, we're going to filter them down. If we complete it, we're going to go ahead and update that value. So there's a problem though, right? Like this isn't real world because you never ever have everything in your application as a simple array of things that are going to happen, right? Applications happen over time. They last a long time. And if you watched the last talk from Matt Popsaki or anybody else who's talked about observables today, right? We have a solution for this. We treat everything as a stream, right? So if we look at this previous example, which is to-dos, and again, we've got this array of actions here, we're going to reduce them. So that works kind of in theory. But if we jump forward to observable land, we can do the exact same thing. And instead, we'll treat inputs to our system, instead of as an array, we'll treat them as an observable of actions, right? So you could think of that as clicks or drags or whatever. And then we'll do that same reduction function, except that in observable land, right, we have this other function called scan. The problem with reduce is it waits till the end of the array before it gives you the result. And so scan works exactly like reduce, except that it'll give you the intermediate value. So each time you dispatch a value to it, it will give you the intermediate state. And because it never ends as an observable, we can effectively treat this through entire application lifecycle and kind of continually get the updated state, right? So again, we take this observable actions that could come from anything, and in this case, we're just going to give it from an array. We take an observable of those actions and we scan over it. We pass it our reduction function in the previous slide and give it an initial state of empty arrays. And then what we do in observables is we subscribe to that state. And so each time we get a new action down the pipe, we'll get the new state that pops out the other end, right? Everybody okay with that idea so far? And so let's kind of see a demo of this. What we'll do is, like everything else, we'll build a to-do list application. And apologies, because like I'm on the Angular team and I'm terrible at CSS, so this is not going to be like a Cara level kind of material design demo. But I am using material design a little bit here, but apologize for kind of the bad CSS ahead of time, right? So what do we got? So this is your basic Angular Bootstrap function, right? We've got a demo app. And what we're importing from NGRX store here is a function called provide store. What provide store takes is the kind of application configuration, right? So if you like, you can think about NGRX store as a database, an in-memory database for your application, and each kind of reducer that we're going to describe is like a table, right? So if NGRX store is a DB, then a reducer is a table. It's not really the right analogy, but it's close enough for this kind of talk, right? And then I've got my reducer functions here. So this is that to-dos thing that we saw on the slides. Again, we've got an array of to-dos. We're going to start with an empty state here, and then we've got some actions: add to-do, delete to-do, et cetera, right? We've also got another, which is a visibility filter. And so what this allows you to do is basically have a reducer effectively for every kind of entity, model, whatever you want to describe in your application, right? So you would have probably one reducer for users and actions and any number of things you store in your application. You just have a reducer for it. So what provide store does is it basically sets up, kind of configures, if you like, the internal database for store. And what allows you to do is then you get to your application itself. So I'm going to go down here, and what I'm doing is actually injecting store. Since the store is the actual service that NGRX store provides, right? This is a service that's injectable anywhere in your application. I like to think of it a lot like HTTP or any of the other kind of services in Angular 1 that you had. It's a primitive, right? It's a very kind of simple service. It's injectable everywhere. It's a singleton, and this is how you interact with store. And then the other thing to notice here is store is strongly typed. So I have in here, somewhere in here, I have an interface that tracks the actual type of information that's coming out of this, right? So this allows me to have a type-safe reduction function. This is one of the reasons that I wrote kind of store over Redux, is it gives you this ability to do TypeScript stuff, right? And so the way that you interact with this, so in my app, what you do is you get store, and then you have, it's an observable. Store is just an observable, like anything else observable, and you can subscribe to it. So what you get out of this is the states. And then what you can actually do is then you say store.dispatch some action to it. And so an action in NGRX store and also in Redux has a type, which is a string. So in this case, we can say like anything. And then it takes a payload optionally. In this case, I'm just going to do like foo bar. And so this isn't going to affect anything because this is like an action that nothing knows about. But if we look here in the console, what we should see, if I can go to the console for you, is we'll get an object of the state of the application, right? So we don't have any to-dos. We have this visibility set to show all. And each time we dispatch an action, we'll get a new state. So just to kind of show you that in action here, if I wanted to do something like store.dispatch a type of add to do, and then a payload of, I don't know, text, hello world. We're going to subscribe to store. We've done that. I'll take out this one for you. And what we should get, if demo gods are with me, is, so we get this initial state with no to-dos, and then we've dispatched a to-do. So now we can look in there and we see we've got a to-do here in the application, right? So that works nice and easily. And so let's actually use this in kind of a real world context. So what I'm going to do is, instead of subscribing, because typically what you'd think if you were using an Angular 1 kind of way of doing this, you would do something like store.subscribe, and then you go like this.todos equals the state.todos. And you can do this. This is absolutely fine. But obviously in Angular 1 or in Angular 2, we have the async pipe, right? Everything in Angular's view understands observables. So what allows us to do is I'm going to just do this. I'm going to say this.todos is store.select. So select is actually a custom operator we've added to this observable. And it gives us a couple of options. So the first, sorry, Mike Ryan, but I'm always going to do this one first. Store.select can take a string, so I can say to-dos. So that's just obviously the name of the entity, right? So that to-dos here matches with the name of my reducer here, matches with the thing that I provided to my provide store function here. Alternately, if you like type safety a little bit more than me, you can do store.select the state. It takes a function as well, and you can do state.todos. And so what we've done here is sliced out a section of the store state, right? We've gone in here and we've said, I only care about this little portion of state, and now assign that observable. So now to-dos is an observable of any, and I should actually change this now to, where is that? What I want to do is go into the app and say to do, and I need to import that from my to-do from /reducers to-dos. I believe it's in there, right? So now it's type safe. And so what I can do then is on my to-do list, so I have a little component here. It takes the to-dos property, and I'm going to use the async pipe to unwrap it, right? So there's almost no logic in the view here or in the controller here whatsoever. All I've said is make this observable available to the view, and then I'm using this async pipe to unwrap it. So if we look at our to-do list components, it takes an input of to-dos. And what I want you to notice here is that there's nothing observable going on inside of this component, right? Like it's not async, you don't have to think about it, because all this to-do list component cares about is that it gets to-dos passed into it from above, right? This means a couple of things. It means you don't have to worry about the asynchronicity. It means it's very reusable. It's not injecting any services. It's not doing anything kind of specific to this context. All it cares about is that it takes some to-dos. The other thing that's really interesting about this is that it actually allows us to do something quite clever. So we can pull in this change detection strategy here, and we can tell Angular change detection strategy, and we're going to say change detection strategy dot on push. And what this means is that all of the components and all of the child components of this component will not be, they're not going to get change detected. They're not going to do a comparison check to see if they're dirty, because we know, we can guarantee that the only way data is going to change, it's going to come in from above. And the async pipe that we're using will actually go ahead and mark this as dirty for us. So this gives us a big performance boost. If we have a really big long list that's getting data from above, it means we can just shut it down and say, ignore this until the observable fires us a new value, right? So we've got that change detection strategy on push. And then we go back to our app here. So again, just to show you, that's to-dos is assigned like that. And then I've also got a component in here called new to-do. And so new to-do is using a little bit of material design stuff, and it's got an action output. And so its job is to just allow you to enter a new to-do. I'm actually using ng model here just to get the to-do text, right? That's available here on the controller. And then what I'm saying is when I click the button that says add to do, go ahead and call this action.emit. So that's going to spit this action. And what we're using here, and this is a pattern that I quite like, is that this is the action that NGRX store cares about, right? So we can just dispatch that out as if it was an event of sort of any normal event. And then again, what I'm doing is in my app itself here, listening to that action event and just dispatching it into the store, right? So that lets us just basically connect the store kind of listener directly to this component's outputs, again, with almost no logic in the view whatsoever. So if I now go into my component here, let Webpack do its thing and say like learn NGRX and add that. It works. Hooray, that's good. So it's a basic to-do list, right? We can say like learn Angular 2, add. And the other thing we've got going on here is in our to-do list, we've also got a string of actions from it as well, right? So if we look at our to-do list, it's got an output of actions. And then the one thing we want to do is obviously in a to-do list, we want to check them off the list, right? We want to make them completed or not. And so again, inside of this component, we do a little magic. We have our check property, so one-way binding, and then we have our change, which is a one-way event. And we say set status, and we pass through the event and then to do. And then again, we like create this action object that NGRX cares about, which is this to do object here. So we're going to say type is update to do, pass the payload of an empty object with the to do, and then the completed property coming in from the view. So in our app, we listen to that, right? And we just dispatch that through the store. So we can do this. This all works. And if I change this here, everything's groovy. I'm just going to show you the kind of longhand syntax of this again. Let's say store.subscribe. And so you've seen me do this a couple of times, right? Where I'm kind of, I want to see what's going on in the store, and I'm going to console log this out. And this is fine, but obviously your friends are going to make fun of you, right? Because you're console log debugging, which is never cool to do. So don't do that. Do this, you'll see the state change, and I add these checks. You'll see each of these things will change, right? So what we can do though, oops, I didn't actually mean to kill that there. One of the things that I really liked when I saw the first implementation of Redux was time travel debugging, right? I mentioned that at the beginning. So Mike Ryan and I talked about this a little bit, and I kind of went around in a circle for a little while, and Mike sent me a PR a few months back. It was like, oh, hey, by the way, like I've implemented this entirely amazing NGRX debugging thing. So what I want to show you is, and I think this is probably the first time this has been seen on stage. If you're using NGRX yourself, you've probably played with this a bit. But we have an NGRX dev tool components. I'm just going to add that in. I've injected it down here, or added to the directives right here, right? So what's going to happen is in my app, what I've added now is this kind of hovering side panel on the left of the screen, right? So as I do things in my application here, so I can say like learn NGRX and learn Angular 2, what it's showing me is every action that's been dispatched into the store, right? It's gone and it's done, it's affected the state somehow. And what you can do is at any point in the application, you can look at what that payload was. So I said add to do, or what the state of the application was at that point in time, right? So again, it started with this, and then if I have another one, I can log the second state here, and I had 2. So it allows me to kind of look and see the history of my application, right? This is really useful when you're trying to debug a really complex application and you're like, what's going on? How does this work? What did I do? You can always look back and see like, how did this work? The reason we call it time travel debugging now is if I do a couple more things here and I say like, like learn the dev tools. So you see I've added 3 to-dos, right? And my state now has 3 to-dos. If I log it out here, I can show you that, yep, there are 3 to-dos in my array. But what's super clever about this is I can say, actually, what would the application have been like if I hadn't dispatched that second add to do? And so I can just cut it out of the equation, right? And the application then recomputes from that point in time where, like, what the application looks like. So at any point, you can stop back and say, I don't actually care about this or this. And it allows you to really incrementally step back and forth to your application state. It should work if I'm doing this. I can actually test this. You can say I'm updating to-dos. And if I go ahead and cancel this one, what's it like at the point that I added this to do, didn't do this update to do, but actually did an update to do after it? So it's really clever. And then you can say like, okay, I actually want to commit at this point and then keep going forward and do more stuff. This is a really, really super powerful pattern, right? It's really, really an interesting way to do this, I think. I think Mike and Brendan are also working on a dev tool for the router as well to allow you to kind of step back and forth through the routing. But this is something that like that blew my mind for the first time, and it's something that we really want to make a big deal with NGRX. So it's in there, you can play with it, it's available on GitHub now. Cool, so NGRX, like I said, it's an organization that we really want to be like kind of a premier place for Angular 2 stuff. If you have ideas, please come and talk to me after the talk. I'd love to talk about it. The really cool thing about this dev tools idea is that in Redux land over in React, they have a huge amount of these different debuggers. They have one that's like built into the Chrome console. They have one that's, they have all different kind of views. So this kind of Redux dev tool thing we have here is a very simple component that can be extended to any number of different things. So again, if you want to come and kind of work with that, please come and talk to me. That's pretty much all from me. Go try this out. Go try the router out. Send me any comments, concerns on Twitter, and thanks for having me.
Woo! Yeah.
Okay, guys. Well, that's it from me.
Awesome. Hey, John, do you have a meeting after this? Okay. So we got to be out just a little before 1, Tyler. Did you want to have a discussion?
Oh, do we have discussions afterwards? Is that it?
We would like to. We were trying.
Yeah. Does anybody have any comments?
I think one of the things we're trying to ask about these topics is like, where do you see maybe one of these things applying in the work we do here? You have an idea, Josh?
Yeah.
Josh would say everywhere.
Everything's a stream.
You took the words right out of my mouth.
There you go.
I can hear you.
It's another mental cognition switch from imperative style programming to functional to reactive using observables and RX. When you start thinking of your application in terms of just streams, it's amazing how. I mean, again, you have to learn new APIs, but all of your user interactions are, well, not only your user interactions, but everything that happens in your application is handled in one way through streams. It makes things a lot simpler doing that.
Yeah, it's definitely a different paradigm. You have to think about things a lot differently.
Mm-hmm. Looks like we're starting to lose our video. Tyler, do you want to offline the new topics for next week part? I'll just do that on chat.
Yeah, sounds good.
All right, thanks everybody, and thank you, DJ Metalbeärd.